Hi all, am I audible at the back? Repeat link for. Okay. How many of you are sleepy? Come on, you all look like. Okay. Besides that, I'll try not to make this a lullaby. Let's try. Okay. Hi all. I'm Utkarsh, and today I'm gonna talk about low latency OpenFS on Ubuntu. Okay, who I am? I'm a I'm a open source developer. That's majorly what you wanted to know about me. The context. Robots today generate, I mean, gigs of data. What I want to do is uh, have the low latency around the edge devices because I don't want to utilize the uh, cloud dependencies. I mean, let's have this project. Uh, there are slave drones and there is a master drone. All these slave drones will be collecting data from LiDAR and GPR. GPR is a ground penetrating radar. It will collect data that will be processed, that will go to the master room, that will send the data to the processing room that will contain the ROS. Um, what bottlenecks do we have right now? Like NFS has jitter loads. SSH copies are way too inconsistent. ROS bag syncs are bad. We had someone talk about MQTT. Okay, they are not suited for the bulk data. What we need is a system that is offline friendly, has low latency, has smart cache, simple to integrate, and can be consistent over different architectures. What do we have? We have OpenFS. I mean, it's ancient. I mean, it's way too ancient, but it has some pretty good features like client-side caching, uh, uh, callback-based coherence, volume-level partitioning, and low-overhead RPC. Works offline. We'll see how. Okay, how do we actually uh, going around this? We'll make of OpenFS low lit. We'll try to uh, have OpenFS give us low latency over the edge devices. How we'll go around that? We'll make some configs around that. Um, we'll have Linux run low latencies and help hardware. That's the main question. Uh, Canonical teams at Canonical helps. They connect with vendors to help hardware get to the real time systems. What is the architecture diagram we are like the project I showed you, the slave and master runes. What's the architecture diagram? AFS servers, there will be AFS servers. Ideally, it will be our x86 architecture. File servers, volume servers, and there will be uh, VLDBs. Uh, there will be high capacity SSDs. AFS clients, basically on the edge devices, will be having Raspberry Pis, and you could use Qualcomm's Rubik devices as well, and there will be shared volumes. What this enables? The real-time LiDAR streams ingestion. I mean, all I want is zero human in the loop while install. Let's like I could not show you how to install this, but there are some commands I have given for you. Installing OpenFS on Ubuntu server side. We'll be installing file server and DB servers, creating a file server boss entry, partitioning volumes, and giving default core AFS volumes, creating LiDAR and GPR volumes as well. This will help us define the data in the background. Now installing AFS on Ubuntu, on the edge devices, we'll be first we'll be installing the OpenAFS for the client and configuring it for uh, uh, the edge devices. Uh, then restarting the OpenFS client. We'll have our own cell. We'll be tuning AFS for low latency. How we'll do that? We'll increase the cache size. We I have personally used cache size of about 600 MB in our project, and increase the callback response. Uh, a default in default it's around 70 second, but we have given a 10-second query for the call that to decrease the recovery time. Let's say I have a server that goes down at any moment, and I want to check whether the uh, sh- client can handle server or not if it's down. Reduce RPC round trips. It's 2 to 2 power 22 bytes. Will be pre-warming files useful for ROS maps. This preloads for the file into local cache manually. It gives us a lower overhead over what the that actually makes us kind of offline, because we don't want our whole file system to be in a one place. What real time tuning matter? Why real time tuning matters? Robotics is when I hear robotics, I all I think about is how time sensitive the system could be. Even AFS organizations, let's start uh, minimizing the time duration for the excuse me. Huh. Let's minimize the time defaults. There are irregular delays over the kernel. We'll be reducing that. First, what we'll be doing is separating the cores for the important tasks. Like, I don't want random kernel threads to interfere with my uh, process. That let's say my drone is flying at an X altitude, and the next step that the drone was gonna do was captured by the cron cron job. That I don't want to happen. We'll edit the grub. We'll isolate some cores for the jobs, update the grub, reboot the system, and allocate the PID to those CPUs, to the CPU cores. We'll do the real time scheduling. We'll What we are doing is we are using FIFO 99. On the scale of 0 to 99, we are allocating the 99 for the maximum uh, priority. For the networking stack optimization, we'll create a config file uh, in which we'll increase the buffer size of the packets that's gonna be held in a NIC. Uh, will increase the RMM size, the maximum and minimum buffer size, prevents socket buffer. It prevents socket buffer too small. We ensure TCP can auto scale. This 4096878380 and this 16 megabytes of space is like minimum, default and maximum values are present here. We'll apply the config file, and we expect okay huh, we expect the packet start the network optimization happens. Okay, OpenFS cache optimization. We edit the afs.config file, like we have seen. We'll pre-warm this servers. We pre-warms the critical files at the client side. Now we start whatever we have done. We have made sure that our systems run in low latency space. Now what I want to do is I want to monitor that That's whatever is happening is going fine. Um, so cyclic tests will be seeing the kernel side latency. I mean, we'll try to figure out what's uh, making our system laggy. We'll use BPF for the OpenFS side of things to figure out what's happening there for monitoring. ROSPUS OpenFS integrations. I mean, there are some shared parameters YAML files that the robots read the same config with callbacks. There are map files, slam maps, and occupancy grids. Bad file logs. It's basically a black box recorder for my bots. Um, I don't want the there are no sync scripts needed. Uh, if I integrate ROS with OpenFS as everything. Um, we have used this in our project and our latency fell down to 420 milliseconds. Well, not to use AFS. I mean, we don't want it when we are gonna use it as databases or extremely high frequency write multiple. I don't want to use it when there are multiple writes happening in very frequently, or when my bot really needs a zero latency bot to bot messaging. Uh, there we could use gRPCs as well. Okay, using AFIS as the file system backbone and not as the database or the message bus. Well, the key takeaways will be we have fine tuned the Linux kernel and we have configured the OpenFS according to our needs. This will kind of help you to minimize the latency around any project. It is field tested on LiDAR and GPR systems. I could involve many more sensors in the near future. Well, that's it. Thank you.